The observable universe is believed to contain 10 trillion galaxies. And in just one of those galaxies, there are an estimated 400 billion stars. 11 billion of those are classified as yellow dwarfs. Roughly 1 in 5 of those stars have planets orbiting them inside a ring called the habitable zone, a region which may be able to support life. And within those billions of planets, we've only found one able to do so: Earth. But could there be more intelligent life out there? And if so, why haven't we seen any signs of them? Nobel Prize-winning physicist Enrico Fermi pondered this very idea and asked an electrifying question that would inspire scientists the world over to try and answer this strange phenomenon. Enrico Fermi was born September 21, 1901 in Italy. In 1926, at just 24 years old, he was elected professor of theoretical physics at the University of Rome. During his time there, he discovered that nearly every element would undergo a transformation when subjected to nuclear bombardment. This work ended up being used as the basis for the discovery of nuclear fission and led to him being awarded the Nobel Prize for Physics in 1938. He became one of the chief architects of the Manhattan Project, which would lead to the development of the first nuclear bombs. During a lunch in 1950 with Emil Nopinski, Edward Teller, and Herbert York, Fermi asked a simple question that would spark discussion for decades to come. The discussion had nothing to do with astronomy or with extraterrestrial beings, said Teller, recalling the event years later. I think it was some down-to-earth topic. Then, in the middle of this conversation, Fermi came out with a quite unexpected question. Where is everybody? The result of his question was general laughter because of the strange fact that in spite of Fermi's question coming from the clear blue, everybody around the table seemed to understand at once that he was talking about extraterrestrial life. York recalls that Fermi followed up with a series of calculations on the probability of Earth-like planets, the probability of life given on Earth, the probability of humans given life, the likely rise and duration of high technology, and so on. He concluded on the basis of such calculations that we ought to have been visited long ago, and many times over. If the universe is teeming with intelligent life, as the calculations suggested, then due to the sheer age of the universe, one of those alien races should have happened upon our solar system by this point, or left some evidence of their existence. This is the paradox. But it was the question, not the conclusion, that has sparked debate ever since, causing a flurry of theories to support and disprove Fermi's lunchtime ponderings. Doug Vakoch, president of Messaging Extraterrestrial Intelligences, also known as METI, a non-profit dedicated to sending signals into space in order to establish communication with extraterrestrials, had this to say about the Fermi Paradox.
It's really kind of puzzling because in SETI, we look for radio signals. Radio signals could travel at the speed of light. We've been doing it on and off for over 50 years. We haven't detected anything. Does that mean they're not out there? Even though there are some people who think the aliens have come to Earth, there's no concrete scientific evidence of that. But even if spacecraft travel at a fraction of the speed of light, they should be able to get here if they've been out there trying to travel for millions of years. And so the Fermi Paradox is this puzzle about if, in fact, there is intelligent life in the cosmos, why haven't we yet made contact? And so I think the critical thing is to imagine possible explanations that let you do something different to try to find contact.
You'll hear more from Doug as we dig into 4 prevailing theories that aim to answer the question, where are they? Theory 1. We're alone. Could it be possible that we haven't heard from intelligent extraterrestrial life because there are none? Are we the only intelligent life amongst the unfathomable vastness of space? Some say Yes. Michael Hart, popular astrophysicist, examined in his 1975 paper titled An Explanation for the Absence of Extraterrestrials, why we might be the only intelligent life in the galaxy. Hart believed that if intelligent alien life is not unique to Earth, then at some point in the 13.5 billion years of the Milky Way's lifetime, some of those civilizations should have developed interstellar travel. If you think about it, humanity is relatively new on the scene. If life is not unique to Earth, then there has been plenty of time for other civilizations to leave traces all throughout the galaxy. Once a civilization made it off planet, it is assumed that species would start expanding outwards. If their spaceships traveled 1/10 the speed of light, and the colony started building more ships as soon as they arrived on the new planet, then the entire galaxy could be colonized in a mere 650,000 years. On this point, Carl Sagan mused, if colonization is the rule, then even one spacefaring civilization would rapidly spread in a time much shorter than the age of the galaxy throughout the Milky Way. There would be colonies of colonies of colonies.
Decade after decade, century after century, and we find absolutely nothing. Again, I think slowly it's going to dawn on us that because we've committed to this search, something more ambitious than anything humanity has ever taken on before, that we have in fact become that long-lived, stable civilization we've been looking for out there all along. So it's a profound search, whether we find something or whether we find nothing out there, as long as we're able and willing to do the search.
What if the distances between stars hosting habitable planets is so great that it isn't possible for life to travel between star systems? Frank Tipler, a mathematical physicist and cosmologist, believed at some point in their evolution, an advanced civilization would develop self-replicating probes that could explore the galaxy for them. So, even if the distance between stars were too great for intelligent life to traverse, they could send drones in their place. Voyager 1 and Voyager 2 can be seen as early precursors to intergalactic probes that other species would have already achieved. If this is true, space should be teeming with intelligent self-replicating drones, and yet we have no physical proof that our solar system has been visited by even one. On Earth, it took 3.5 billion years for intelligent life to form under just the right conditions. Life might just be incredibly rare. An intelligent radio signal producing life, even rarer. But some scientists say that doesn't mean it doesn't exist in a universe as expansive as ours. Theory 2. We haven't looked in the right place. The problem could be that we're not looking in the right place or for the right signals. Jill Tarter, an astronomer from the Search for Extraterrestrial Intelligence Institute, SETI for short, said in 2010 that it was silly to conclude intelligent aliens do not exist nearby just because we haven't yet found their beacons. Even if such signals exist and are aimed right at Earth, her thinking goes, we've scanned so little of the sky and may not be looking for the right type of signal or for long enough to find them. This problem is compounded by requiring our telescopes to be aimed at just the right spot, at just the right time to detect a signal. Shubham Kanodia, graduate student at Penn State's Department of Astronomy and Astrophysics, has co-authored a research paper titled How Much SETI Has Been Done: Finding Needles in the N-Dimensional Cosmic Haystack. In the paper, Shubham and his colleagues attempt to quantify the amount of searching that has taken place to give perspective on whether we should have found something by now or not. He likens the search to having searched a drinking glass worth of seawater for evidence of fish in all of the Earth's oceans.
So suppose I tell you tonight that there is this really cool event happening in San Francisco, and that if you find that, that will be the best thing in your life, and that's going to be this really life-changing thing. But I don't tell you where in San Francisco it's happening. I do not tell you what time it's happening. I don't tell you if it's tonight, if it's next month, if it's next year. I can't even tell you if it's already happened. But there is this event that might happen there that if you were to find, it would be amazing. So now suppose I told you San Francisco, if I didn't even tell you that, if I said there's something really cool happening on Earth, now how long will it take for you to search for that? I do not tell you the time, I do not tell you the place, what it is, etc. The implicit message behind that is before we say, okay, we've been looking for the last 40 years, because that's what many detractors say, that we've been looking for the last 40 years and we haven't found anything. But the truth is the amount we've actually looked in this gigantic framework is so small, we can't really say we've ruled anything out. We can't say we've placed any upper limits on the broader picture. There have been searches which have looked at the star, and okay, you can say that this star or this stellar system, we do not see anything that is being transmitted in this wavelength region at this time for the 5 minutes that we looked. That's the only constraint you can place, but you cannot say anything about that. There doesn't exist a civilization on that star, let alone in the entire galaxy or the fraction of the galaxy that we've looked at. Because the fraction we've looked at is so damn small.
Frank Drake, founder of SETI, aimed to predict the amount of communicable intelligence in our galaxy based on both known and speculative factors. With this in mind, he created what is now known as the Drake equation.
He realized that they were trying to get at this question, how many civilizations are out there right now trying to transmit? So he said, well, what do we have to know in order to estimate that number? And so he wrote out a series of 7 terms, and if you multiply them together, you get what's now called the Drake equation. And so the 7 terms start with the astronomical, and they move up to the more societal. So the astronomical terms, first thing you have to know is how many stars are there in our galaxy. So the first term is the rate of star formation. Then for those stars, you need to know what fraction of those stars have planetary systems. It's called F sub T. Then of the star systems out there, how many Earth-like planets are there? Potentially habitable planets per star system. So that's called N sub E, the number of Earth-like planets. Then once you have a planet that's potentially habitable, what fraction of those go on to develop life? That's called F sub L. Then once you have life, maybe microbial life, how likely is it that that's going to lead to the evolution of intelligence? So the next question is, what fraction of those life-bearing planets has intelligent life, F sub I? And then of those planets with intelligent beings on them, what fraction go on to develop the technology that lets them communicate at interstellar distances like radio and laser? That's called F sub C. And then the 7th and final term, perhaps the greatest unknown, is the longevity, L, the lifetime. And by lifetime, we don't mean how many years since their species first arose, but how long have they been sending out signals? What's their lifetime in terms of a lifetime that we can detect? And so you multiply all of those terms together, and you get some approximation of how many civilizations are out there right now.
Through this estimation, it is believed there could be anywhere from 10,000 to 100,000 civilizations. If that's the case, where are they? One such possibility proposed is that intelligent species only exist for a very short period of time. They succumb to their own intelligence through warfare and environmental damage.
But if that's the norm, then it's incredibly unlikely that their 100 years and our 100 years are going to coincide, given that the galaxy is 13 billion years old. I mean, it's as unlikely as if 2 fireflies each flick on for a single moment over the course of a dark night. What's the chance it's going to be exactly at the same time? Virtually zero. So the only way we make contact is if the other civilization has been out there doing this, either listening or transmitting much longer than we have. And so in essence, we're trying to look into our future. We're trying to find a civilization that has a stability of its own civilization, of its own capacity to search, far beyond anything we can imagine.
The Drake equation is commonly referenced when discussing possible life in the universe, but many of the variables cannot be reliably filled in.
It's an important formula because it gives us a ballpark sense that, this is a plausible search. And over the decades since that was first formulated, we've gone from having a really pretty good estimate of one of those terms, the rate of star formation. And now, over the last 20 years especially, we've come to a much better appreciation of how many planets are around each star. When Frank did his first search, he had no direct evidence that there is a single planet out in our Milky Way beyond our solar system. And now we know there are billions of them. So there are a lot of places to look, a lot of real estate. The big question is, in those later terms of the Drake equation that are harder to quantify, does life appear and does it take a form that we can communicate with often enough to make contact? And do they keep at it long enough?
Regardless, we have in fact detected a few anomalous signals in our short time searching. There's the WTF star from 2016, which was an atypical light pattern from the dimming of a star between the Cygnus and Lyra constellations. While no radio signals were detected from this patch of the sky, the anomalous dimming still hasn't been explained. One theory for the dimming is that something artificial is blocking the light. Currently, the Allen telescope array is pointed in the area of the anomaly in hopes of locating any non-natural radio signals. From July to August 2018, the Canadian Hydrogen Intensity Mapping Experiment Radio Telescope of British Columbia recorded a number of fast radio bursts, including one that repeated 6 times. This repeater signal was the second time in our history scanning the skies that it has been detected. Fast radio bursts have started to become more and more common and have remained a mystery as to their exact origins. Some have theorized these bursts could be artificial in nature and originate from alien civilizations. Other theories for their origin include young neutron stars exploding and supermassive black holes spitting out radiation. We shouldn't immediately label any anomalous space signal as evidence of an alien race. There is still so much we don't understand about our own universe, and taken out of context, a signal could be misinterpreted. For example, there's the infamous WOW signal from 1977 discovered by Jerry Eyman of Ohio State using the Big Ear radio telescope. The WOW signal was a 72-second burst of radio signals from a group of stars called the Chi Sagittarii. It's now widely believed that the signal was caused by a pair of comets that were passing near the patch of sky that was scanned. This pair of comets carries with them a cloud of hydrogen gas millions of kilometers in diameter that would have caused just the signal that was detected.
The last thing any SETI researcher wants is to falsely flag a potential signal as artificial when it's just some weird natural phenomena. And we've seen that happen repeatedly. When we discovered pulsars, we jokingly called them little green men because it was such a strange phenomena which we hadn't seen in nature before. Likewise, now in the recent last 10 years, we've seen Voyager stars, which in the Kepler data, which has this transit light curve that we'd never seen before, and people started attributing it to extraterrestrial intelligence and potential forms of super advanced civilizations that we do not know about. But now the most likely scientific consensus is that it's most likely a swarm of dust or comets or something like that. So people are very worried as well as cautious about how do you flag these signals and how do you interpret them.
While anomalous signals from space are exciting, extraordinary claims require extraordinary evidence. We have so much to learn about the universe that it is more likely a rogue radio signal comes from a natural process rather than ET origin. But listening to space for signals from other civilizations is some of the most exciting and promising research in the search for extraterrestrial life. We should continue to support any endeavor in this area, especially the research being conducted by METI as well as SETI. We've only been actively searching for intelligent alien life for 60 years. Who knows what we'll find in the next few hundred? Theory 3. We don't know what we're looking for. The third theory argues that it's possible that alien life could be so utterly foreign to our conception of biology that we don't even know what to look for. It has been speculated that life might be able to use silicon for cells rather than carbon. Like carbon, silicon can form bonds with up to 4 atoms simultaneously, which makes it well suited to forming long chains of molecules that are conducive to life as we know it. Because silicon bonds differently than carbon, these cells would look and act very differently from our conception of a cell. It has even been theorized that Titan, one of Saturn's moons, could potentially host silicon-based life. That life would use hydrocarbon, which is found in massive lakes on its surface, as a solvent instead of water. This form of life would be totally unfamiliar to anything on Earth. It's exciting to speculate what sort of exotic life forms could be waiting to be discovered in the Milky Way alone. Any life in our solar system would be simple, most likely microbial forms of life. But what would a silicon-based intelligent society look like? Would they follow the same technological evolution as us carbon-based life forms? Or would they develop in ways we can't predict, and as such, can't even begin searching for? Astrophysicist Nikolai Kardashev developed a scale to help rate intelligent life based on its technological development. It's worth noting that we human beings haven't even completed the first tier. The Kardashev scale is as follows. A Type 1 civilization has figured out how to harness all the energy on its planet. Humans are getting close to achieving this. Type 2 civilizations are so intelligent that they figured out how to harness all the energy of their own star. It's an incomprehensible amount of energy compared to what is available on Earth. That's nothing compared to the Type 3 civilizations. These have harnessed all the energy available in the galaxy. How can we expect to understand civilizations who have made it to Type 3 when we haven't even fully grown into a Type 1? What forms of communication might these races employ, and how would we even know what to listen for? Think about how much technological progression we've had in the last 50 to 100 years alone. Imagine an alien race who has surpassed our own by 1,000,000 years. The technology of that race would be so far beyond anything that we could begin to comprehend that we may not even know what to look for. Arthur C. Clarke said it best when he said that any advanced alien civilization's technology would appear as magic to us. Just as if we brought a human from the Stone Age into modern day and tried to have them understand and recognize our modes of interacting. MIT radio astronomer John Bell wrote extraterrestrials may be beyond our intellectual horizon. Some of the phenomena that we already see may be associated with ET, but we don't understand. The comparison he draws is to that of an ant wandering through New York City. The ant has no conception of the humans and their intellectual capacities operating all around them. Theory 4. They're watching us. Is it possible alien life just hasn't wanted us to find it? John Bell was the first author to write about the concept of the zoo hypothesis. The zoo hypothesis theorizes that there are intelligent alien life forms in the galaxy, but they are purposefully avoiding making contact with the human race. They may be observing from a safe distance, not wishing to interfere with our species' technological and societal development. Doug Vakoch had this to say about the theory.
Maybe there are other beings out there watching us, much like we watch animals in the zoo. But what happens, is imagine you and I go to the zoo and we see a bunch of zebras. What if one of those zebras turns right toward us, looks us in the eye, and starts counting out a series of prime numbers? That would really give us a radically different relationship. You might go down and check out the wildebeest, but I'm going to stick around with that zebra, and I want to see if I can get a conversation going. Let's say the zoo hypothesis in its strongest form is true, that the extraterrestrials out there, they're watching us. They are very disciplined zookeepers. No matter what we say, they're going to think, almost like in Star Trek terms, the prime directive. Sorry, we can't interfere. We're not going to let you know we're here. We're just going to watch you. I mean, if that is what's happening in the strongest form, then there's no way to distinguish between that response and there being no extraterrestrials out there at all. So the only thing we can do is to find some variations of that strong zoo hypothesis, so a weaker zoo hypothesis in which maybe, in fact, some responses, some attempts to make contact will yield a response. And again, if you want to think of the Star Trek analogy, sure, according to the Federation, you're not supposed to mess around with another civilization, but when those civilizations themselves reach out and start attempting contact, then all bets are off, and it's okay to welcome them into the cosmic conversation. It could be that the sustainable civilizations are the ones who've learned to work within their means. That in fact, maybe the civilizations that keep a SETI program going for thousands or millions of years are the ones that are more modest in the signals they're looking for. And so those civilizations, though they don't have the technology that would be threatening to us. They haven't been able to come to Earth, but maybe they've been looking for a signal. Those civilizations, we could make a difference by sending an intentional signal.
It could be possible that we offer no value to them and pose no threat. So why should they even bother communicating with us? You have to wonder if this is the case, would they still remain silent once humans gain the technology to leave our own solar system? What if they're already watching us? What if we can't recognize them? What if we haven't looked in the right spot? What if we're alone? Sometimes it may seem that all that's popped up since Fermi asked his infamous question nearly 70 years ago are more questions. But there are people looking for answers. In June of 2019, NASA's Curiosity rover's tunable laser spectrometer, called SAM, discovered the most amount of methane ever measured during its mission on Mars. The main source of methane on Earth? Microbial life. While NASA cannot conclude whether it is biological, it has poured more fuel on the fire. If there is life within one solar system, could there be more around the septillion? That's a 1 with 24 zeros after it. Stars that fill the universe. And if there are, where is everybody? Let us know why you think we haven't found evidence for alien life on our Twitter and Instagram at strange_phenom and Strange Phenomenon, all one word, on our Facebook. Please give us a review and subscribe on your favorite podcasting app. Visit www.strange-phenomenon.com for a full list of sources and more episodes. Strange Phenomenon is hosted by Ray Tarara. It's written and produced by RJ Blake and Ray Tarara. Theme music by Tara Monk. A special thanks to Douglas Vakoch and Shubham Kanodia for sharing their insights and knowledge with us. Learn more about Doug's work at METI.org and read Shubham's paper, linked in the show notes. Additional music provided by Sergey Cheremisinov, Meydän, Kevin Hartnell, and additional stock media provided by LucorMusic from Pond 5. Links to the artists' websites are available in the show notes.